Hi my friends, today we study this part, counterweight. This is the first piece in an assembly that we will then study by using the dynamic simulation module in Inventor. It is a medium complicated part. What's important is this plane on a round part. There would be some problems, but I think we can deal it. This is the drawing. You see all dimensions here. As you can see, here is a cylindrical end of the part. After everything is cylindrical on the other direction. Yes, this line is for the flat surface, not round. This you can see better here. Yes, this is a plane face. Okay, let's start. We start by creating a first sketch and a plane XY. We start by drawing the axis with a height of 90 to have an idea about the scale of the part. This is a center line. Then we start with this contour and then the inside contour. Yes, this is the main view with the data for the contour. Yes, but here we have gauge dimensions: 90, 182, 162. Here is another dimension for the sloped line. Let's create this contour external. From here, a radius up, another radius. You know the procedure. Then up, round, round to up, and then to the left. Okay, let's dimension this start. Constraints this line to be coincident, to have coincident this point, and this line with this end. Yes, angles. (22), 45, 68. Radius, this is 3, this is also 3, and the bottom is 6. The diameter here is 182. And this is 162. The end here is 56.5. Here is something not tangent. Yes, it was. Another dimension is a diameter of this point, 114. And this one is 77. This distance 18. And now we can continue. We continue with this contour to here, because the cylindrical part will be generated after. So I have to go to 20 with a thickness of 7.5 on horizontal, yes? Then to this contour, 15 degrees is here. I start with 15 degrees, another line, another, and this one. Let me place 15 degrees. You see, I use firstly angles, very important. Diameter of 110 of this point, and 82 here. 82. Okay, this angle is 34. And this point is at 11 up. Let's continue here. Line from this point, horizontal, vertical, and then at another angle, a radius, a tangent, another sloped line, and let's dimension this. Yes. These 2 points are on the same vertical. You see this here. Yes. And 7.5 the thickness. So same vertical for these 2 points. Dimension here is 20, but not as a diameter. 20. Okay. This is a diameter of 76 at a height of 60. This is a radius of 8, very important to be placed before. I continue this line because there is a dimension here. You see? This. The tangent to the radius 8 arc is continued here. So, line to a point. This will be a normal line. You'll see why. This point at the height of 50, and then collinear this line with this line. Okay. Diameter of 72. 72.5 for this point. This is connected with a slope line. Let me draw it. Line to here. Oh. Same point. They share the same point. Good. Now, this is diameter of 66. And we have some dimensions here. 1.5. This is placed. Okay. 70. Diameter 70 here. And 14 is this. .31 is this point. That's all, my friend, here. Let's see what is the situation up here, because the 7.5 is needed here, and 48 is the final. Okay, everything is white now. Finish sketch, revolve. Both are to be selected, and when we go here, Inventor knows that this is a center line. I don't create a whole circle, but symmetrical, only 90 degrees I develop here. Yes, and this is the first interesting volume. I assign the material to see all the time the final material. Style still austenitic. Now I create this contour as an extrusion to intersect with the existing volume and to obtain this all the way down. And then we continue to create again this round face outside of the core. This is the core of the part. Let's see what are these dimensions. 25, 16, 45 degrees is this short line, and 35. Let's create this contour on the base plane, or here on this plane. I project this line and this line, because here I finish. I make all of them construction lines. I draw a rectangle about here. I make tangent this line with a circle. I place on the same horizontal the midpoint with the center point. 25 is here, and line, line, and close. Yes, this line is also tangent with this circle, and the midpoint is on the same horizontal with the center point. 45 degrees. I don't create symmetric. I apply again the same angle. 35 is this dimension. And 16 here. I don't delete this line, I make it construction line, because I want to maintain the integrity of the rectangle, the first rectangle. Finish sketch, extrude, intersect all the way up. Okay, we have the core. Yes. Now we share the first sketch. This is the first sketch. Share sketch. It becomes visible, and we apply revolve of this part only, not all. Yes, this part of the sketch of the closed area, because we want to regenerate the cylindrical or revolving object. You see which one. This face is common to the core and the revolving object, again symmetrical on 90. You see, this is very interesting and very nice. Visibility, F6. Let me present it so, and we have a very much part of the part. Okay, I want to make now these cuts, yes, 2.5 from the end and 94 here. I make this by creating another volume with intersection like before. Okay, this is construction, but I want to project some other, this, any of this, and the end. I make them also construction lines. Again, construction. And now I draw a line like this, to the center point, and this, not construction, they are good to be parallel with the part, faces of the part. Trim the ends. This is okay. Dimensions here of 2.5. 2.5. And horizontal lines, not this, from this point to this point, and a symmetrical line. To be symmetrical, I make them equal. This is a good technique in such situations. The dimensions here is 94. And trim to have a close contour. This is to be on the same horizontal with this. Now is okay. We continue with the circle to this extreme part of the part. Extend this line and this line, trim this all, and make equal again these two lines. Finish sketch, extrude, intersect all the way. Okay, this is our part. Now I go to this cylindrical end of the part, which has a diameter of 9 and the length is 16. On this face I draw a circle. Let me make this construction. A circle with the center of that 20 distance line, vertical line, circle with diameter of 9. Finish sketch, extrude again, to this face, but join, not cut. Okay, that's good. You'll see why is this necessary when we create the assembly, as I promised. Take care to look at my next tutorials to see this. Now let's continue with this hole, which is placed at 68, 72.5 and the diameter of 16. This face where we place a point. F7 to see everything. Dimension from the base, this point, is 68. And dimension from the center point is 72.5. We have a point. We create a hole, which is cylindrical. The point is already selected. Through, tab, tab, tab. This 3 must be changed with 16. Okay, now there is a new hole which ends to this center, and it starts with this point. We have to create this point, yes? This point, which is on the axis, which must be also created. The angle is 22, and we start by creating this plane. Yes? Look here. Plane, axis, and now I select this plane because I want to create a sloped plane somehow like this. This is minus 22 for us. Okay, this plane intersects. I create an axis at the intersection of this plane with this plane. Yes, the midplane of the part. Now I want to find that point. point is placed at the intersection of this line with the y-axis. Yes, y-axis. Look at the point. Now we don't need this anymore, and we have that line. Dimensions: diameter of 6 is through to this hole, and then diameter of 10 with the length of 63.5 from that point. So hole from this point on this direction to this axis with a diameter of 6, my friend. Okay. The other hole starts from here, has the same direction or direction, and is on a distance. The distance is 63.5, and the diameter is 10. Okay, this is no more necessary. Also this. Okay, you see, everything is in the proper place. Very good. Now I see a small mistake here. This must be ended with a flat side, so we have to create a cut. Yes, you see here 16, this cut. Yes. Let's edit what this extrusion, the sketch of this extrusion, line, vertical, at a distance of 16. Trim the rest, this arc, finish sketch, and the flat face is created. Good. Now we go back to what I said at the beginning. Here must be flat faces outside the core part. If we take a look, we see this plane, which is the separation, intentional separation made by me between these two closed areas. So I want to find again this line to create a plane along it on the sides of the part. Not a big problem, but a little tricky. Okay, this is the sketch. I make it visible in order to create an axis here. Yes. Now I don't want to see the sketch. I need a point here, so I create this point at the intersection. We made this before with this axis. Yes, I created this point. Now a plane perpendicular on this line and through the point. Now I create a sketch in this plane. Okay, this is the point, very important. I project only a side is important. I project a side. It is the only important. And this side. And also this. Extreme sides. Why? To create a rectangle which is this is good, this point with this line, this with the previous point, and this here. We want to cut only this. There are no dimensions here, my friends, you see? Finish sketch, extrude, cut all the way. Okay. You see the difference? Here is curved and here is flat. I make not visible all this work, geometry, elements, and I apply mirror to this about the XY plane, and the same will be created to the right. Okay, good. This is our part. All we have to do now is to place that holes, this, at a level of 32 from the base, 32 from the mid plane, and metric 10, 13 is the total depth, and 10 is the depth of the thread. Okay, I create the plane at 32. Plane 32 minus 32. A plane for a sketch. F7. A sketch with a simple line which will be converted to axis. 32, finish sketch, axis, and the sketch is no more necessary, and also the plane. A point on this axis and this face. Hole in this point on this direction. All the data are already placed because I made the part before. 13, 10, metric 10, normal pitch 1.5, and that's all. Okay. Visibility and mirror of this hole about this plane. You see Okay, that's all, my friends. What is the volume? Now we are looking for the volume, yes? 171,416 is the control element if you want to create this beautiful part. Thanks for watching. Bye bye.